Welcome back, everybody. This is going to be our presentation for Lab 8 for both CAD 1133 and 2131. Today we're going to be talking about creating a hookup drawing, some 3D model, and additional parts for your project. Originally we had talked about how Proteus was so fantastic. You're creating our schematics, for creating our PCB layout, for creating our bill of materials, and this wonderful 3D image that you see. I had alluded that we could actually take this and export it into other CAD systems, and that's what we're going to do today. So why would we want to export 3D out of Proteus? We want to do that because often we need our mechanical model to suit our electronics model as well. So we want the mounting holes, our clearance, our wiring harness, everything to match up perfectly. We'd also want 2D images for presentations, for management, for approval processes, for user manuals or technical hookup diagrams. So without any further ado, here we have an example where I took our project and I exported everything from Proteus and put it into AutoCAD. And you can see that there is way too much detail. We don't need the backplane. We don't need all the traces. We don't need all this information. It becomes very cluttered. So what I'm going to do next is I'm going to walk you through how to actually export a proper file. So I'm going to go ahead and pause the video and get out your project file, and we're going to carry on. Now that we have our Proteus file open, we can see that everything is laid out the way that we want it. We can go ahead and export our file. And the way we want to do that is find the Output tab. You're looking for Export Graphics and Export DXF file. This will open up your export menu. You're looking to export the top copper. We don't need the bottom silk, but we would like bottom copper, but we do need the top silk. We'll keep the mechanical layer for now, and we can get rid of the resist and paste layers. We also want to set a file location. In this case, I've created a desktop folder called Proteus LAB, and I will call it simply 2D for now and say OK. Now we need to go ahead and open up AutoCAD. So pause the video and come on right back. Okay, now that we have AutoCAD open, we're going to go ahead and open the DXF file. We do that by saying File, Open a Drawing. You're going to want to set it to DXF format. Browse to the file location where you placed your DXF file and go ahead and open it. And you should have something that looks like this. And it's a little busy. It's more than we need. And so let's go ahead, take some time, and you want to delete any of the traces that you don't need. Now we wanted to keep the top copper layer because without it we're missing a lot of detail, especially for the pads. And so this will allow us to have a very neat drawing when we're done. Yes, it takes some time now. It's a little bit tedious, but attention to detail at this point makes for a very clean drawing. So go ahead and erase all of the traces that you don't need. Anything that you don't like, you can go ahead and delete. Some of it will be easier than others, but come on back when you get to the point where you feel that it is clean enough. Okay. Okay, so as you can see, we've cleaned up their drawing and removed all of the extra lines and vias that we don't need. I also took a moment and used the burst command, and that will remove a lot of the excess hatching and make the drawing a lot cleaner and neater. Once you finish this, you're going to want to create a new tab and import the template file from the first semester so that you end up with something that looks like this. Make sure that you go ahead and lock your viewport before you start doing too much as far as your labels. And these labels are simply using the leader command, okay, and you can modify it as you need to suit the layout you want. Because what we're really looking for at the end of the day is something that looks like this, okay? It doesn't have to be exactly like this, but you know, I have a description of each of these headers and what they do and kind of how they connect. And feel free to vary from this as you feel necessary, but you can use this to describe what each of these sections actually do. Okay, so this is all that we need to do for the 2D portion of the homework. And so go ahead and pause the video, and I'll continue on in a moment with the 3D portion. Alright, here we go with the 3D portion of our homework. And so the next thing that we're going to want to do is to export this entire file. And the way to do that is, again, through the output drop down, you're going to go to generate 3D MCAD file. You can go ahead and leave it on step. You are going to want to point to the directory wherever you've been working. For me, it's on my desktop in Proteus LAB, and you can create a name. In this case, we could call it 3D, and this takes a few moments as it has to create all the surfaces for every object on our PCB. And there we go, it's finished. You can see that it did complete. So I can close this and open up my AutoCAD. From here, you're going to say File, and you want to import other formats, and you will find in your directory that step file. When you go to do it, remember down in the corner there's the little hot link to show that it is working. And once it finishes importing, you should have a model, an actual 3D model of your PCB. And from here, you're going to want to import it into a drawing tab. Ideally, you're going to have the same border and title block, but I'm just going to shortcut that for just this moment. And so I'm going to say Layout, Base, from Model Space. Sure enough, that's fantastic. I'm going to pick my orientation. I want the top, and it looks good to me. And I'm going to change it from hidden lines to actually shaded, just because, and call that fantastic. You can definitely use orthometric dimensioning the way that I did in my example, but you're not required to. If you want, you can absolutely pick linear dimensions. It really doesn't matter to me. What I want to see is that you actually have imported a file and given it some some dimensions. Critical dimensions that we're looking for would be, you know, the width and the length in metric and imperial, or just imperial, it doesn't really matter. The hole size and position, and you're good. That's all I need for the 3D portion. And so go ahead, pause the video, and get this finished, and when we return, I'll talk about the last few items that we need for our project. Okay. All right, so we're getting very, very close to finishing up our project. There's a few objects or a few items that we need to add to our bill of materials in order to make our project work. One thing that we're absolutely going to need is a power supply. Now we could make this run off of 5 volts and use the USB, but for safety reasons for your computer, we're going to use a power supply. And so I've provided for you a power supply. Feel free to use something similar, but do mind the voltage. You don't want to get too far away from these specifications. It could be an AC unit if you wish. We do have a full bridge rectifier, if you recall, but we also need to attach it to the PSU. And so one of the reasons why I chose to do this was it gives you the opportunity to actually take a power supply, cut the end off, put our own connectors, and it's a great learning experience. Okay. A couple of clarifications on some parts. You want to make sure that you order the right rotary encoder. It should be the one with a switch in it. Okay. The next thing is we can add a biasing resistor to the 3.3 volt output or input, your choice. And the reason for this is that if we ever connect it backwards, it will short out through this 1N4148 and not destroy your board. Okay. And yeah, definitely include the connectors for your in-circuit serial programmer and the display, which I've labeled in mine as M1. Now, some optional parts for those that are a little keen and are interested in working on this through the summer. You can order a programmer that will allow you to actually program the board yourself. And I'm going to circle back to the circuit board itself in a minute, but yeah. So there's also a display that you could choose, and if you're going to go at this, let me know and we can have a further discussion on it. But there is a display that you can get and a keypad, and if you want, there is a Pro Micro that you can plug into it, and if you remove the microprocessor and use the Pro Micro, you can access all of the peripherals on this board. If you do get around to soldering it up, make sure that you use sockets everywhere. So you should include as auxiliary parts or extra parts in your bill of materials sockets for anything that you can. So any of the ICs that are through hole, absolutely include the socket. It's easier to solder. If you make a mistake, it's easier to remove and definitely less expensive to replace. Okay. Just a tip about soldering in general: make sure that you always solder the shortest parts first, and then work your way up to the bigger things. And don't power up your circuit board until you prove out the power supply. Okay, and so the first thing that we always check is continuity. And so yeah, make sure that also when you first power it up, so your power supply looks good and you're going to put power down everything, make sure that you remove your ICs so that if there is a short, it doesn't cause a huge problem. But you should always check for short circuits with your digital multimeter. Okay. Okay. Now, as far as the project, the issue that we're going to have is we're not going to get access to the labs before mid-April. So there's very little opportunity for you to get your circuit boards, populate them up, and get them into me for programming. But that's not fair. And so what I'm going to do is I'm going to make sure that at some point, either at the end of this semester or at some point next semester, I will give you your circuit board and you can populate it, and I will program it for you, and we'll continue and do everything that we said we were going to do. But I can't grade you on it because this situation isn't going to allow it. So do I get you to order the components? I'd really like you to, but I can't mandate it. Not at this point. But if you don't do it now, you're probably going to have to do it later. And as much as I'd like to get you your circuit boards now so that you could actually order your parts and have something to work on while you're stuck at home, I don't know that that's feasible. I am planning on checking into whether or not I can mail these out to you, but at this point we're gonna say I'm going to remove any grading as far as the soldering and the assembly of the circuit board. Okay. If you have any questions, please feel free to contact me through my email, and we can have a further discussion. And definitely post comments if you want any extra video on how to do any of this. Okay? Talk to you soon.